Hello guys and welcome to another video. So in this video we'll be solving for x using law 2. Now here's our first problem. We have 3 to the power of 2x is equal to 27 over 3 to the power of negative x. The first thing that we are supposed to do, guys, is to change, or rather is to have all of our bases being similar to one another, and we can see that 27 is not a common base as 3 from these other bases, so it has to be converted into a common base of 3. Okay, so that's what we're going to do. So what we will have is 3 to the power of x is equal to, how do you write 27 as an exponent? We basically, for us to change 27 into a common base of 3, it has to be written in a form of exponents. So for us to write 27 in an exponential form, we should say 3 to the power of 3. When you say 3 to the power of 3, you get 27, and then at the bottom we'll have 3 to the power of negative x. And then on the right hand side, I have two bases that are dividing each other, right? So because these bases are dividing each other, I'll take the one at the bottom to the top, right? So I'll have 3, I forgot to write 2 here. It's 3 to the power of 2x on the left. So on the left, it's 3 to the power of 2x is equal to, on the right, under the same base, I'll write 3 to the power of 3. This exponent at the bottom will be taken to the top, and when it goes to the top, it's going to change into a positive, right? Now that I have bases that are equal to each other on either side of my equation, it means I'll make my exponents be equal to each other. So what I will have is 2x is equal to 3 plus x. Then this x I'll take to the side. 2x minus x is equal to 3. What is 2x minus x? It's x is equal to 3. So therefore, that is what my x is in this case. All right, I've solved for x on that particular problem. Let's move on to the next one. In this one, we have 16 to the power of x is equal to 8 divided by 4 to the power of x minus 1. Okay, first things first, we have to change our bases into common bases, right? 16, for us to write 16, it has to be, for us to solve for x here, every base has to be similar to the other, right? So we are going to write 16 in an exponential form, or rather 16 to the power of x in an exponential form. We know that when you say 2 to the power of 4, we get 16 is equal to, on this side, when you say 2 to the power of 3, we get 8. And here, when we say 2 to the power of 2, we get 4 to the power of x minus 1. Then, when you proceed, we are going to remove our brackets by multiplying the exponents with each other. So, here we'll have 2 to the power of 4 times x. We'll get 2 to the power of 4x is equal to, this side we'll leave the numerators is divided by, at the bottom we will have 2 to the power of 2 times x, we'll get 2x. 2 times negative 1 will get 2. Now on the, let me write, on the left we leave everything as it is. On the right hand side, because I have bases, two similar bases that are dividing each other, the exponents should subtract from one another. So the ones at the bottom will go to the top and change in their signs under the common base of 2. So I'll have 2 to the power of 3. This 2x will change into a negative 2x, and this negative 2 will change into a positive 2, right? When we proceed, because on either side of my equation I have two bases that are similar to one another, I will make the exponents to be equal to each other. So on the left I have 4x is equal to, here I will have negative 2x, and then I'll add these two when I drop them down. 3 plus 2 is supposed to be 5, right? And then this negative 2x I'll bring to this side. I'll have 4x plus 2x. When I transpose it to the left, it becomes positive 2x is equal to 5. And then 4x plus 2x is 6x is equal to 5. Then when I divide by 6 on both sides, I get x as 5 over 6. And that is our solution to this particular problem. Right, let's do another problem. So this one is 4 times 3 to the power of 2x is equal to 9 times 2 to the power of 2x, right? How do we go about solving this problem? First things first, we are going to make bases become similar to each other, okay? Since I have a 2 here, I know that I should change this into a base of 2. Since I have 3 here, I know I should change this 9 into a base of 3. So I'll start with 4. So 4 can be written as 2 to the power of 4 times 3 to the power of 2x is equal to 9 can be written as 3 to the power of 2 times 2 to the power of 2x, right? Now that I have similar bases, I'm going to group them together, okay? I will divide by 3 over, I will divide by 3 to the power of 2 on this side, and then I will divide by 2 to the power of 2 on this side, or vice versa. It's up to you which order you prefer. So let me see. Let me say, the approach that we should actually use here is that we'll divide bases with similar exponents with each other, okay? So what we will have is that this particular power will be divided with this one. So what we will have is 3 to the power of 2x divided by 2 to the power of 2x is equal to 3 to the power of 2 divided by 2 to the power of 2, right? When we proceed, we will take out, since there's a common factor here, we will take it out. So when we take it out, we will remain with 3 over 2 is equal to 2x is equal to, this side as well, we'll take out a common factor of 2. Our common exponent, let me say common exponent, not common factor, since we are not factorizing. Common exponent, 3 over 2, outside we'll have 2. Because these bases are similar, the exponents will be equal to each other. So we will have 2x is equal to 2. When we divide by 2 on both sides, x will become 1. Okay, so that is the final answer for this particular problem. If you didn't understand, feel free to let me know in the comment section. See you on the next video. please like the video likewise. Bye bye.